April 10th, 1963. The most advanced submarine in human history dives off the coast of Cape Cod for a routine certification test. She never comes back up. More than 60 years later, the Navy will not tell you the full story of what killed her. Not really. No, it was not a Soviet torpedo. No, she did not dive past her crush depth. The USS Thresher died from 3 engineering decisions that were built into her on purpose. 129 men went down with her, 16 officers, 96 enlisted, and 17 civilian shipyard workers who came along to watch her pass her final test. Every American submarine that has ever sailed since exists in her shadow. Every welding standard, every inspection rule, every safety protocol in the fleet was written in her crew's blood. And the worst part is not the flooding that started it. It is not the reactor shutdown that made it fatal. It is what happened to the one system that was supposed to save them. But first, you need to understand how she started dying. For decades, the United States Navy joined seawater piping the hard way. You welded it. A welded joint is slow, expensive, and brutal on the welder, but when it is done right, it is stronger than the pipe it connects. You can X-ray it, you can inspect it, you can trust it at depth. But in the late 1950s, Portsmouth Naval Shipyard switched gears. They standardized silver brazing on thousands of joints throughout the Thresher-class seawater systems. It was faster, it was cheaper, it was rated for the pressure. And that last part turned out to be a lie. Silver brazing has a fatal flaw. A brazed joint can look perfect from the outside, shiny, smooth, correctly shaped, while being hollow, voided, or cold on the inside. You cannot see it. In a swimming pool, it does not matter. At test depth, every square inch of that pipe is carrying more than 600 pounds of pressure. A bad joint does not leak. It detonates. After Thresher went down, the Navy did something quiet. They pulled her sister submarine, USS Tenosa, out of the water and ultrasonically tested the silver brazed joints nobody had bothered to reinspect. The results were bad enough that the Court of Inquiry refused to print the exact percentages for years. Roughly 14% of tested joints failed Navy quality standards. 14%. On a submarine already commissioned, already crewed, already at sea. When one of those joints let go in Thresher's engine room that morning, a submarine became a high-pressure fire hose aimed at the electrical panels. Water did not flood in. It atomized. And that alone would not have killed her. Thresher was built to survive a flooded engine room. She had propulsion, she had ballast, she had reserve power. She should have driven straight to the surface. Except the moment that joint failed, a second engineering decision kicked in and made absolutely sure she could not. Earlier, American submarines could take a hit and keep their reactor alive, flood a panel, isolate it, keep power on the screws, and get home. But by the time Thresher sailed, naval reactors had rewritten the rules. Admiral Rickover's engineers standardized automatic reactor scram, an emergency shutdown, for a specific set of electrical anomalies. The logic was sound on paper. Protect the reactor core from damage. The crown jewel of the fleet must never, ever be compromised. So at the first whiff of electrical trouble, the reactor shuts itself down. Hard. Immediately. Here's what that meant at 1,300 feet. A scrammed reactor cannot be restarted in 60 seconds. The restart procedure at the time took minutes. Minutes the Thresher did not have. A Thresher-class submarine without reactor power has 2 options. She can run on steam reserves, which bleed out in moments. She can run on batteries, which cannot push 3,700 tons of flooded steel upward through a quarter-mile of ocean. Neither option buys her a surface. The reactor almost certainly scrammed within seconds of seawater reaching the electrical panels. It did exactly what Rickover's rules told it to do. It saved the core. It doomed the crew. And the quiet admission came years later, buried in a naval reactor's procedural revision. The scram restart protocol was modified after Thresher, specifically for at-depth emergencies. That change is an obituary written in engineering manual form. Once the reactor dropped, the crew had one card left on the table, one final system. Punch the high-pressure air into the main ballast tanks, blast the water out, ride the buoyancy up. It had saved submariners since the Great War. It was going to save them. And it is the system the Navy built to fail. Every submarine carries thousands of pounds of stored high-pressure air for one reason. You punch a valve, the air screams into the ballast tanks, the water gets shoved out, and the boat rockets toward the sky. Simple, physical, reliable. Submariners have bet their lives on it for 100 years. On Thresher, the air was stored at around 4,500 pounds per square inch and piped through fine mesh strainers to keep particulates out of the critical valves downstream. Standard design, industry standard. Here is what nobody in that design meeting apparently remembered from high school physics. When compressed air expands through a small orifice, it cools violently. Adiabatic expansion. The faster the air moves, the colder it gets. On Thresher's air system, the temperature at the strainers during a full emergency blow dropped low enough to freeze any trace moisture in the lines. And there was moisture in the lines. There is always moisture in the lines. The strainers iced over. The air throttled itself. The emergency blow built its own wall against itself. This is the part that makes your hands cold. The harder the crew tried to save themselves, the more ice they formed. Every second of blow built more blockage. The Thresher's own survival system fought her crew to a standstill. After the loss, the Navy quietly ran emergency blow tests at depth on her sister submarines. The ICE formed exactly as suspected. Some boats reached only a fraction of the expected airflow before total blockage. Every sub-safe redesign since has required dehumidified air and re-engineered strainers. The only reason every American submariner alive today is alive. The last coherent message from the Thresher was 11 words. Experiencing minor difficulty. Have positive up angle. Attempting to blow. Will keep you informed. Attempting. The word they chose on the radio in their last conscious seconds was attempting, because the air wasn't making it. The blow that was supposed to save them had already frozen shut. 129 men died listening to the sound of ice choking their own rescue. And that is what the Navy spent the next 6 decades covering up with a program called SubSafe. So what was the fix? A program. SubSafe, born in December 1963, 8 months after Thresher went down. Since the day SubSafe went into effect, not one certified American submarine has been lost at sea. Not one. Every weld is documented. Every joint is traceable. Every piece of air piping is dehumidified and engineered to survive its own use. It works. It has always worked. It took 129 dead men to write it. Every time a corporation, a shipyard, or a manufacturer tells you that a new method is faster, cheaper, and just as safe, remember the Thresher. Silver brazing was faster, cheaper, and considered safe. It killed her. Automatic reactor scram was safer for the Corps. It killed her crew. Standard strainers on high-pressure air were industry standard. They froze shut while her captain was still talking. The Navy still does not say the word ice in its official summary of April 10th, 1963. Now you know why. They named a submarine after her. They should have named a warning after her.